In this following demo, we're going to demonstrate leaking multicast from the underlay to the overlay. So you're leaking multicast from the physical bare metal network, from physical bare metal multicast server across your multicast aware network via PIM and IGMP, and then leaking it to the virtualized network to the overlay. But note, this is not flooding traffic across your network or flooding traffic to the overlay. This is leaking traffic to desirable tenants in the overlay network. So tenants that who are IGMP aware and have requested that specific stream. So that's the setup. In the setup, so we're leaking from underlay across the network to overlay, and we're only flooding out or replicating out the multicast stream for the desired tenants. So to set this up on the VSD, you need to go to infrastructure on the database, and on the infrastructure in the database you create the multicast address range that you want to allocate to that cloud, to that organization, or to that customer. So an example here, we've allocated 239.250.1/24. So once that's been created onto the database, you can then assign it to the specific private or public clouds. This is assigned again under the database and under the organization profile. So you might have a different organization profile per customer. So under the organization profile, you can say what you want as your multicast receive and your multicast server. So what streams you want your clients to receive, and what streams you want your clients, or you want your servers, your virtual servers, to send. So once that's done, you will allocate that address range to that specific customer. So once that's done, then under the customer, an example here, we've assigned it to OS test customer. Under the OS test customer, you go back to networks, and I have a setup here called dev multicast. Under dev multicast, under the domain, you assign what customer is gonna have that address range. So under the domain itself, it's assigned under there. Once it's assigned under there, that's about it for leaking traffic multicast from the underlay to the overlay on the VSD side. Then on the actual VRS side itself, on the VRS, what you need to do is update the OVS, the Open vSwitch, the VRS configuration. And the way you do that is you assign under the VRS, you assign what interface is going to be your multicast interface for sending your IGMP joins out, which receives from the underlying tenant VMs. Those IGMP joins are sent up to the Tor. You also assign what multicast stream you want, the address range in there, and that's about it for multicast from the underlay to the overlay for setup. Once that's set up, then we can set up a server and client setup. So in here I have another bare metal server, which is going to be streaming multicast, and it's going to stream a multicast stream to 239.250.1.1. If you look on the router, then on the router, we have a multicast stream that's being learned by the router for 239.250.1.1, coming from source address 192.168.205.2, which is this bare metal server here. So once that traffic is learned by the router is that's been sent to the router is just dropping it at its interface unless it knows of any clients that are aware of it. And it knows of a client that is aware of, so it's got the source SG, which is the source and the group itself, and then it's got the star G, which is a client asking for a specific loop. So then if we go to the VM itself, on the VM itself, we have iPref running on here on this VM. and the iPref. So I've stopped the join. So we can see now there's no join coming from that VM. All we still have is the multicast string being sent into the router from here. So now if I send a join from the bare metal, and we have a look here first on the VRS as well. On the VRS, we can see what VMs are asking for what multicast string. So there at the moment we have no multicast, no VMs asking for any multicast stream on that hypervisor. We can also see the address range that's been allocated to address range. So we can see that we have a transmit range and we have a receive range. We'll talk about the transmit range in a minute, but the receive range is still 239.250.1. So if we send the IGMP join now, so the VM is asking for that multicast stream. So now we can see that there's a specific VM asking for stream 239.250.1.1 coming from this tap interface, and this tap interface is APCTN. Here's 10. So we can see it there, the tap interface, and that's that for that specific VM. So if we do a TCP dump then on that specific tap interface, we should see the traffic going in, the multicast stream going into the VM. So there we are, there's the multicast stream going into the tap interface, coming on from the physical network into the tap interface, into the virtual network. If we stop the stream on the bare metal side, we see that the stream is stopped on the VM, and it's also stopped on the tap interface. And also, once the VM leaves the stream, we create an iPref, and what happens then, an IGMP leave is sent out. We can see that there's nobody else is listening for that stream anymore. So you have complete proxy functionality on the VRS itself. So that's an example of leaking traffic, leaking multicast traffic from the underlay to the overlay VMs.